Energy Trust of Oregon launched the Path to Net Zero pilot in 2009 because we see net zero as the future of the building industry. We're an organization focused on energy efficiency and renewable power. Since we provide financial incentives and technical resources, we're in a position to help transform the way buildings are designed and constructed. Through this pilot, we wanted to make an aspiration a reality. It's not just about building green anymore. It's about changing the way we think about energy and how we interact with buildings, and net zero is what's going to get us there.
When we were designing this pilot, we tried to figure out what owners and designers would need to reach net zero. What we found is that it's not actually about the money, but about connecting the right people. Net zero really needs to be a collaborative effort. So we didn't want to just provide incentives for high-performance, energy-efficient equipment, but we actually wanted to help support the design of the building. So part of our incentives went towards an Featurette, which brings an entire project team together to set energy goals and overcome energy challenges. Another part of our money went to help support the energy modeling and other energy studies that are important for designing a net zero building. By supporting projects in the early design stages, we were able to encourage them to consider passive design strategies, which not only lowers the energy use of the building, but actually lowers the upfront cost as well. We also felt that it was really important for owners to monitor the energy use of their buildings, so we provided an incentive for energy monitoring systems. The data that the owners are going to be able to collect through these systems will help them to meet their energy goals.
The buildings in this pilot were a test for design strategies and technologies, and it's a test that they're passing. We're seeing true success across a wide range of buildings and project types, and we're seeing that low to modest budgets are not necessarily as big of a challenge as people sometimes think. Net zero is a goal for everyone, and we're closer to reaching it every day.
Ecoflots is a 4-story mixed-use building located on the North Williams Bike Parkway in Portland, Oregon.
I saw the opportunity when the economy slowed down that we could change directions. We could take a new course. We could really focus with the more limited resources on what people really needed, what was going to benefit the greatest amount of people. And what popped up was the Path to Net Zero program. And I thought, oh, this is perfect. This is exactly what we want to do. This makes sense. We designed a building that had specific costs in mind for what people could afford in a neighborhood. When you approach a project like this, you need expertise on board to see how what things are going to apply and what are going to be the biggest bang for your buck, as it is. But where are you going to go to be able to integrate HVAC with solar thermal, interacting even with plumbing and all kinds of different specialists? You have to be able to go to one central place where that can be understood. And so that's the Energy Trust of Oregon.
One of the great design features of this building are the exterior walkways, which help to save a lot of energy.
What we've been able to accomplish here is that there's no heating or cooling or conditioning provided to these exterior spaces whatsoever, and the lighting is only being used in the evenings.
Well, making the decision to incorporate exterior corridors instead of interior walkways really eliminates the need to heat and cool those spaces and results in annual energy savings of around 10% per year.
The apartments are able to be pushed all the way to one side of the building, allowing for cross ventilation, natural ventilation, to cool the units in the summertime. In the day when you're gone on a hot day, you close your shutters from the inside, and in the evening you come home, you open your windows, turn on your fans and open your shutters, and you can relieve any hot air that might have built up during the day. And that, for this temperate climate, is all you need for comfortable living. The siding itself is a ceramic coated material that has a 7/8 inch air gap behind it. So on the hot days of the summer, this being the west facing part of the building, the heat is prevented from penetrating the building by hitting that ceramic layer and ventilating out behind before it penetrates into the building. Solar PV is the first thing that you want to be able to bring to a project. So what we had to do was to design a building that could be affordable and meet the rents of the neighborhood and add essentially a $125,000 solar array.
The solar PV system generates about 18,000 kilowatt hours annually, which results in an energy savings about 20% off the utility bills.
The way we were able to accomplish this was with the energy incentives and the elimination of AC units and the future maintenance costs of AC units. That's basically how we were able to add it. These are hot water tanks that are banking 600 gallons of hot water from our solar thermal system. The system we have in place on a normal sunny day can generate 2 gallons per minute to 185 degrees. In a long day, we generate a tremendous amount of energy.
Because domestic hot water is one of the biggest energy users in multifamily buildings, it made a lot of sense to put a solar thermal collector in this building. In this building, it saves about 700 therms per year, which translates to about $1,000 off the utility bills.
This Honeywell sensor is testing the outside air temperatures, and it's sending a message to the boiler to tell the boiler what it should be doing. And it's a heat-only system on this building. It's extremely efficient, and it's also heating the retail core, including a restaurant and its makeup air.
For us, it was a natural fit to locate in Ecoflots here as a net energy zero project. It was important to me that we capture or benefit from some of the energy efficient systems that he put into place, such as the hydronic heating. We captured that in our loop here, and the envelope, naturally, we benefit from.
In working with the project teams, one of Energy Trust's biggest priorities is to really work with the teams closely to ensure that we're maximizing energy savings as well as getting the right systems incorporated into these projects.
Their engineers were working on this project as much as we were in order not only to verify the studies, but also to enlighten us to things we might not have thought about. Ecoflots is designed to be a highly reproducible model. We feel we can build it anywhere along the West Coast and we'll be able to achieve the same results. No matter what you provide, in the end, the person flipping the switch is going to be a big part of that decision. There's a solar panel on the rooftop, and are people going to feel less conscious of how much energy they consume because there's so much energy being generated on site? And that's where we decided to develop this energy monitoring system in a way that it would be available for everybody in the building to see all the energy consumption and be able to positively influence one another.
When we come home from work, we'll see what appliances bump your energy use. So you'll be like, oh, we cooked a lot in the last 2 days, or we ran the washing machine or whatever, and you'll see a spike in your energy use.
Supplying them information, we feel, is the only thing we have to do to really make the difference.
I think just being aware of energy use makes you just think of, like, are we using it in excess, you know?
You're influencing people to make the right kind of decision.
It just puts it on your radar, so you just think about it.
The developer didn't just create a place that was extremely energy efficient, but also a place where the tenants would be engaged in making smart energy choices.
The Ecoflots building came in at about 55% more efficient than a typical code-compliant multifamily building built in Oregon, which puts it well on its way on the path to net zero.
Junque Delta Community Center is a public assembly building located in North Portland. When the Portland Alumni Chapter of the Delta Sigma Theta sorority decided to renovate this old gas station into a community gathering place, they really demonstrated their commitment to sustainability.
It's a community center, but it's also our Delta House where we have our meetings and our activities.
They wanted a place to run their programs.
We have the community garden space, workshops on health, working with youth, giving scholarships, youth organizations that do mentoring. We have a senior citizen component.
They had a space that was quite a mess. I mean, they had tile on the floor, expanded metal mesh on the windows, chain link fence around the outside. So they wanted a place to meet and to be able to run their programs.
And the mission of this building, being a living building challenge, is basically to emphasize sustainability on a grassroots level.
But then they also wanted to do something more than that. They wanted to say, hey, we want to be part of the green movement. We want to do this. We don't know everything that's necessary. All we know is that we want to do it.
It was an evolution from green to greener to the greenness.
What they brought were a lot of givens. It was essentially, this is the reality of the situation, and this is what you need to do.
And so when opportunities like the Energy Trust came along, we were just excited.
It was very supportive that we had these people ready to help us.
We knew what we wanted, but these opportunities came our way, and we were ready for it.
One of the first activities that Energy Trust participated in with this project was the Featurette.
It was a brainstorming session, essentially. And it also kind of spelled out, too, what the parameters of this path to net zero were and what net zero starts to look like.
It put everyone in the room that was going to build this building energy efficient.
And what that process told us was that if we are going to do net zero, we would need to use a ground source heat pump. We would need to use these mini split systems. Our envelope was only going to operate so well considering the number of air changes. We couldn't change so much of the exterior because we wanted to keep the existing building. We were trying to maintain a low carbon footprint. That is part of the benefit of keeping the existing building. We've got glass on either sides of this room, huge panels, and as a result, the lights are typically off here during the day.
They had to develop this whole design so it would fit economically, price-wise and also energy-wise.
The Energy Trust engineers were extremely helpful in making sure that what we were doing was something that wasn't just something that we thought was a good idea, but something that, was a good idea.
The building incorporated several design features that got it to its energy efficiency goal of about 60% better than a code-compliant building. The biggest contributor to energy savings in the project was the heating and cooling system, which mainly consists of a geothermal heat pump.
What we're doing is we're switching heat from the ground to the building in the wintertime and from the building to the ground in the summertime. The idea is that we're treating the earth essentially as a giant battery so that over time we'll be taking out and putting back heat in as we need it.
We have created a space where people can see sustainability up front, touch it, see the ramification of what it can do.
The project team was really motivated by a sense of responsibility to the community. It's in the sorority's mission, and it's also at the heart of this project.
People are just really taking this building as a demonstration of what they can do within their own community on an affordable level.
There's one person at a time to start changing your habits, and it's a process.
How do you bring this higher forming sustainable building into the neighborhoods in a way that addresses each street corner?
It got people to thinking of energy as a commodity that can be translated into a building that will work. They want to know about the efficiencies of the lights. They want to redo their kitchen so it looks like ours. The fact that we're doing a lot of recycle stuff, they want to be part of that.
Working with the Energy Trust, they sort of acted kind of as guides a little bit, and also sort of critics as well, so that you could kind of get, you started learning, okay, this is what it is, this is what it feels like, this is what it looks like.
We have found them to just be incredibly helpful, responsive, and it opened my eyes as a layperson to the opportunities that are available through this organization.
What this building represents is what you can do or how you start to take a high level of sustainability and you start applying it to the neighborhood level.
Well, I guess we're a change agent.
Yeah, that's
On
true.
a small scale.
Very small scale.
Yeah.
When I arrived at Hood River Middle School, we had the need had already been established. We were going to put in a building of this approximate size that contained a new band room and then a new science classroom.
We were very actively engaged with students right from the beginning of what did we want this space to look like.
We had a collection of engineers and architects from outside of our community, and then we had students and teachers, school board members were involved in the process. We got together for about 2 or 3 hours and we talked about what we envisioned for the building and how it would best benefit our community and school.
Hood River Middle School needed additional classroom space. They could have gone the quick and easy route, but instead, the school board decided to build to the highest efficiency standard there is.
Since the very start, the project's focus has not just been the cool building, but having a program that instructs, that teaches while it houses kids.
It wasn't systems for systems' sake, but really systems that provide educational learning opportunities.
This building sort of made me realize how much energy we're using and how it's not endless.
Everything that we did, it had to tie to the educational goals and mission of the district, how they teach.
We don't want it quite that powerful, so that's why this valve is here.
The Energy Trust of Oregon was there. They actually came and did a presentation about what the program was to the whole school board, which I think was one of the most important points in the process, because it really took that kind of presentation to say, yes, this is an important program. It has the backing of the Energy Trust of Oregon.
When we were able to look at what the Energy Trust was able to do for us, they set it up so that the board could go, okay, this is a slam dunk, this is easy.
The school board really supported the idea when they realized the building itself would be a valuable teaching tool.
From that point forward, we started to have a conversation about doing something special and unique with the structure when it came to green building techniques and energy-saving technology.
That building over there has a $100,000 a year electric bill. And if we do it right, this building has a $0 electric bill.
One of the most impressive features in the building is the heating system, which is basically a radiant floor system throughout the building, and it ties into a geothermal heat pump system.
We dug a trench along the side, drilled horizontally under this field, and created a geothermal field right here to provide a lot of the energy for the building.
The building is almost 92% more efficient than a typical school building in Oregon, and it did that by incorporating several passive design features such as natural ventilation and solar shading that prevents solar heat gain into the space.
One of them is the trellis that's along the south side, both of the music wing and also of the greenhouse. Both of those are great arbors that in the summer provide shade to the windows and shade to the greenhouse.
The solar PV system is designed to generate about 41,000 kilowatt hours per year, which almost gets the building to net zero and hopefully will in the future. Another unique thing about the solar PV system is that heat generated underneath the panels is collected and used to preheat the incoming outside air and also increases the efficiency of the panels.
And you can see the way the panels have been integrated into the design of the roof so that they really, unless a lot of people, unless you're told that they're there, just think they're part of the roof form.
We can quantify the financial benefits of having a structure like this. But we also have these intangible benefits, this excitement and this ability to have kids think about things that they might not know exists.
What it's really doing is teaching the kids that come through this building every year to understand that they actually use energy.
It's really interesting to to see how the whole building works and like how different things can be used to make a different type of building and just to make it less wasteful.
That's probably the biggest intangible piece is that we got kids that are really asking really brilliant questions to be able to understand the system better so that they can share more about it when people come to see what's going on.
We have a clean out valve, we have an inline valve to here, and it goes up to our diffuser.
The actual interaction between the users and the building is what's going to make it net zero or not.
They're looking at the numbers now, and they're the ones saying, oh, I don't know, maybe we should not run that computer this week.
We should all definitely try to install something like this in our homes, and it would be a lot better if we didn't just rely on like fossil fuels to heat our homes.
And that's pretty powerful stuff when you can have a group of kids sitting around the table saying, we have to lower our use in the last 2 months of school because our numbers aren't right.
Energy Trust was able to support this project with over $85,000 of incentives. This money went to help pay for the technical studies, solar panels, energy efficiency equipment, and the monitoring display.
Oh, it was crucial that we were able to leverage those pieces on top of the money that we were going to spend to be able to get the energy system that we got.
Frankly, for a public school district, every extra dollar that goes into, that's above and beyond what you'd normally spend on a project has to be considered.
And it was around $150,000. You would spend that on a set of math books and not even blink. And those math books are going to last 3 to 5 years. And we're looking at a system that's going to last 50 years and totally impact how kids see the way that they interact with energy.
With support from the Energy Trust, we can clearly say that the payback period for all of these really neat innovations is 12 to 16 years.
Because the users are so actively engaged in fine-tuning the building systems, the data now shows that the building should definitely reach net zero in the next year.
What's really great about this project is that it's a living laboratory for the next generation.
The pilot projects demonstrate that net zero is within sight. Based on their success, Energy Trust will continue to offer enhanced incentives and resources to building owners who set net zero goals. If you're considering constructing a net zero energy building or simply want to learn more, contact Energy Trust of Oregon today.